Hi there, and welcome again to Simplify Math, where I'm here to make math just a little bit simpler in your life. We're going with a little bit more complicated concept this time. We're talking about something called the difference quotient. So, the difference quotient is a little bit more complicated concept. Like I said, it mostly deals with calculus, and it kind of leads us into calculus. You might see it a little bit in pre-calculus, depending on what your teacher teaches you. But this is really dealing with some higher level thinking. And so what the difference quotient is it's a variation on slope. And so it's kind of a way that we can look at the slope of a curved object. So if we think about something with a slope, I'm going to just do an example down here. So if we have a generic coordinate plane here, if I take a slope of any line, let's say something along the lines of this linear equation here, this linear function. If I try to find the slope of this, it's quite simple. We remember our old adage, rise over run. So we're going to take our change or our delta y, change in y, over our delta x or our change in x. Delta in math just means change, by the way. So if you ever seen a triangle in terms of a context of a problem, it just means change in, okay? So that's delta. So this is how you can find slope of a line. Well, that's all fine, except if I pull up a line or an equation that's something along the lines of this, where we have a quadratic now. Well, in a quadratic, this line is ever changing. And so, for example, if I choose a point here to, let's say, here, my slope of this line would be different than if I chose a point from, let's say, here to here. These 2 points are different than these 2 points. They're not the same slope. And so, therefore, we can't really call it slope because they're different here. This is very consistent along its path. So this is kind of where the difference quotient comes in, is we can look at a very specific point and we can actually get a function to where I can actually plug in one of my x values here to find what the slope of the tangent line is at that point. So here's our difference quotient. This is kind of a fundamental, you need to remember this, but this is what the difference quotient is. We're looking at the limit as h approaches 0. So that might be a strange concept. I'll talk about what that means here in a second. So the limit as h approaches 0 of f of x plus h minus f of x all divided by h. And so, remembering what a limit is, in this context, we're going to use a lot of direct substitution when it comes to using limits, meaning as h approaches 0 means I'm going to take h equals 0 and I'm going to plug it in anywhere that I see a 0. Or anywhere that I see an h, I'm going to plug in the value of 0. So that's a good concept here, but notice if I plug it into this, I'm dividing by 0. And remember, we can't divide by 0. That's a bad thing, okay? So in this situation, it doesn't work, but we can actually at least manipulate this depending on what our f value is or our function is to then change it. So let's go to this problem here, and we're going to make it a little bit simpler. We're going to do the parent function of a quadratic, but let's actually look at a quadratic, and let's actually talk about the difference quotient. So I'm going to use the difference quotient to calculate the slope of the tangent line. Okay, so I'll write the instructions up here. Calculate the slope of the tangent line of f of x equals x squared. Okay, so this is my function that I'm trying to calculate the slope of the tangent line, and we'll just put at any value because that is going to change a little bit depending on what value we're talking about here. So calculate the slope of the tangent line of f of x equals x squared at any value. So we're going to take, since it's slope of the tangent line here, we're going to take this value and that's going to be my f of x. So let me start off by rewriting the difference quotient. So the limit as x approaches 0 of f of x plus h minus f of x all divided by h. So what we're going to do is we're going to take this and we're going to plug it in here, which seems pretty basic. Notice f of x here and f of x here are the same value. So that is going to be a direct substitution. This is just going to say minus x squared. But plugging into this part is where the problem gets a little bit more work. Okay, so as we plug this in, anywhere I see an x value here, I need to make sure that it's substituted with x plus h. So when I do this, I have the limit as h approaches 0. F of x plus h. Well, f of x is equal to x squared, which means x plus h is what is getting plugged into this x value. So now it is squared minus x squared all divided by h. Now, I'm going to put this x squared here, the whole thing in parentheses, and I would like for you to get into the habit of that because right now it's just going to the x squared, which isn't too much of a change. But in a different problem that I'll show you here in a minute, that is going to matter big time whether or not we have parentheses there. So I have to expand this x plus h. I can't just leave it alone as is. So if you remember your old FOIL, or there's a little shortcut, but x plus h squared just means x plus h times x plus h. We're doing the FOIL method. Okay, or double distribute if you like it that way. So therefore we get x squared plus x times h and another x times h. So we'll have 2x times h's plus h squared. So this is the value of my first section here. So let's rewrite the limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared. Now, so seeing that there's nothing else in these parentheses, that tells me that I can get rid of the parentheses to just keep the x squared all over h. So once we do our operation here, now I can actually simplify my numerator. So if we notice, I have x squared minus x squared. So those are going to go away. So therefore I'm left with the limit as h approaches 0. By the way, continuously writing the limit is going to make your college professors very, very happy. So continue to write the limit all the way across. So that leaves me with 2xh plus h squared all divided by h. So if you think you're done here, double check. Can I plug in 0 and get a value? Well, if I plug in 0 right here, no, because I still have 0 as a denominator, okay? Or if I plug it in on both sides, yes, I get 0 over 0, but that's what's called indeterminate. You can ask Siri, what is 0 divided by 0? Generally gives you a pretty funny answer. So we cannot have 0 divided by 0 in this situation. So I got to get rid of this h somehow on bottom. Well, if I look at my numerator here, and this will happen a lot when you're doing the difference quotient. Look at your numerator. This value has an h in it. This value has an h in it. So what I can do is I can actually factor out an h. So that leaves me with the limit as h approaches 0 of h times 2x plus h all over h. Now you can always double check your work. If I take this h and I distribute it back, I should get back to this up here. Okay, so all we did was we took an h out of both of these, brought it to the outside. Well, now if you notice, my h's cancel. So therefore, the limit as h approaches 0 of 2x plus h. And so if I do my direct substitution here, I take the 0 and plug it in, I get my difference quotient of just 2x after I evaluate that limit. 2x is my answer. Okay? So this is the difference quotient. It's a lot of steps. Now you could probably shortcut this in general ways depending on how good your math is, depending on how good your algebra skills are. You can maybe shortcut some of this, but this is a very drawn out explanation of what the difference quotient is. Now these problems get exponentially harder, okay? And so I'll kind of show you some examples of what it looks like if I have enough room on my paper, but I may end up skipping some steps, so you'll have to bear with me. So let me show you an example of what it looks like where we got to be careful of these parentheses here, okay? Because those are going to be kind of messy when we start getting a little more into this problem. So same instructions, but this time we're going to let f of x be equal to, let's do x squared plus 3x minus 2. Okay, we're going to make this a little bit more complicated. So still a quadratic, but this one's going to look a little bit different. All right, so we've got our same difference quotient, the limit as h approaches 0 of f of x plus h minus f of x all divided by h. Okay, that's just our generic formula. You're going to use the same one every time. Sorry if my camera's a little bit shaky. I'm on a different table, and so it's kind of causing it to shake every time I write, so bear with me on that. Okay, so let's actually take this and plug it in. All right, now keep in mind, everywhere in my initial function that I see in x, I have to substitute in x plus h. So therefore, when I substitute, I have the limit as x, or as h approaches 0 of, open parentheses, x plus h squared, that's the first part, plus 3 times x plus h, that's the second part, minus 2. Notice the minus 2 doesn't have an x, so I don't have to plug anything in. That's just my first part. Minus, and here's why we need parentheses. Okay, if I just leave this as x squared plus 3x minus 2 with no parentheses, notice my 3 is positive, my 2 is negative. That's not what we need because it is subtracting the entire function as a whole, meaning I have to put parentheses around it. Now, as soon as I put parentheses around it, this negative gets distributed. It turns my 3 negative and my 2 positive. So please make sure you watch your negative here. You have to put parentheses around your second function. In fact, it might even be good practice of going ahead and bracketing or parenthesing around that f of x function. That way you just remember it. Now this is all over h. So a lot of work to be done here. Okay, a lot of work. Now we already did in the last problem this x plus h squared. So that's a good thing. We can kind of shortcut that just a little bit. By the way, as you're going through calculus or pre-calculus or any upper level math, math hates trees. So don't be afraid to waste some paper. Okay, you're going to be using a lot of paper on this. That's okay. Use a lot of paper. Use a whiteboard if you really love trees. But we are going to be using a lot of paper here. So we still have x squared plus 2xh plus h squared. We showed how to do this particular part on the previous example. Plus 3x plus, notice we're taking this 3 and we're distributing it inside these parentheses, 3h minus 2. Now we're also taking this negative and we're distributing the negative. So minus x squared minus 3x plus 2, all divided by h. So that's a lot. It looks very daunting right now. Don't let this scare you. This is very basic algebra. Even though it looks complicated and we're moving into trig, this is very basic algebra, or sorry, calculus, not trig. This is very basic algebra. Notice I have like terms. X squared, negative x squared. Those cancel. Okay. If I go down the line here, notice 3x minus 3x. Those cancel. Notice the minus 2, the plus 2. Those cancel. Okay. So now all we have left, after we simplify a little bit, the limit as h approaches 0 of 2xh plus h squared plus 3h, all divided by, h, not x, h, all divided by h. Notice these terms here that I'm circling are the only ones that we have left on our numerator. Which is a good thing because similar to the previous problem, this one has an h, this one has an h, this one has an h. So what I can do in this situation is take that h and factor it out. You're going to be doing this on almost every single problem, so get used to it. H times 2x plus h plus 3, all divided by h. Similar to the previous problem, these two h's here cancel. The limit as h approaches 0 of 2x plus h plus 3. Notice, now that I'm not dividing by h anymore, I can do direct substitution with this h going to 0. Take this 0, plug it into the h value. That turns that h to 0, which means 2x plus 3. And that is the difference quotient formula for the slope of the tangent line of this function. That is going to be the slope of the tangent line to it every time. So these problems get a lot more complicated, okay? The algebra that goes through these gets much more complicated, okay? Depending on what your initial function is. Any quadratic, linear, anything along those lines, cubic even, they're all going to come out to be very similar process throughout the whole thing. This gets complicated when you start dealing with radicals. Square root of x plus something, that's a radical. It starts getting a little more complicated when you start dealing with fractions. Obviously, fractions are our first favorite F word if you watch my previous video. First favorite F word is fractions. And so fractions get very complicated in this section because you really have to pay attention to combining your like terms because you have to get a common denominator with those fractions. So this is the same process for every single one of the problems, but give you a little bit of light at the end of the tunnel. This does get easier, okay? With the difference quotient is taking the really, really, really long way to get to somewhere. And then after you get done with that, there's a little shortcut that takes like 2 minutes. It's much easier than this. So grit your teeth, bear through this section. Once you get through with this, life will be so much easier. Grass is greener on the other side. I promise you that. So that is the difference quotient. Once again, guys, life is hard. Let me simplify the math. Hey guys, I hope y'all enjoyed this video. I'm hoping to make some more content that's personalized just for you. So if you want to hear some math tips, or if you want to know how to simplify math a little bit more, first off, hit that subscribe button, and then hit in the comments. Let me know what topics you want me to cover, and I'll make sure to get to it. Thanks.